So today we are doing section 3.6. It is all about some properties that you will see with parallel and perpendicular lines. Remember, you have 4 theorems, and then we'll do some notes. You don't have to write this down. I just want to talk about this for a second. So let's pretend that you have a line. Boys. Let's pretend that you have a line and a point. And I say, draw a line through that point that's parallel to the original line. How many lines could you draw?
4.
You could draw 4 lines on that dot that are parallel to this line.
1.
Yeah, the answer is 1. There is only one line you could draw through that dot that would also be parallel to the line underneath. That is our first theorem today.
So when we draw this first?
You need to write everything on the board. It's actually a postulate, sorry, not a theorem.
Well, we don't need to draw this.
You need to do everything on the board. So the parallel postulate says that if there is a line and a point not on the line, then there is exactly one line through that point parallel to the given line. Write everything on the board in your notes, including the title, parallel postulate, and including the diagram. So this is the perpendicular postulate. It's pretty much like the parallel postulate. It says if there is a line and a point not on the line, then there exists one line through the point perpendicular to the given point. So exactly the same as the last one, except now they're perpendicular instead of parallel. Any questions?
No.
All right. Here's the next one. This is theorem 3.11. This states that if you have 2 lines that are parallel, Q and R, and then one of those lines is parallel to a third line, like R parallel to S, then the first and the last are parallel to each other. It's a lot like the law of syllogism that we learned in logic, or the transitive property. You're just sort of cutting out the middleman. So if these 2 are parallel and these 2 are parallel, you can say the first and the third are also parallel. All right, here is theorem 3.12. This is the last theorem of the day, so I know it's been a lot of writing, but you're almost done. This one says, in a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. So you can see in this diagram, M and N are perpendicular to P, so they're parallel to each other. Any questions on what this one states? So you can see just lots of different rules about parallel and perpendicular lines today. So our first example, the directions say use the given information. Explain why A is parallel to C. So they're already telling us that A is parallel to C. We just want to know why. So any ideas on number 1, part A? This comes from 3.1. Any ideas? What does 3.1 say? 3.11, excuse me. You just wrote it down. Not the last slide, but the one before that. In today's notes, 2 slides ago. It says if one line is parallel to another line, and that line is parallel to a third line, then the first is parallel to the last. So again, if 2 lines are parallel, so I said A is parallel to B, and one of those lines is parallel to another line, it's like you can cut out the middleman. So you can just say that A is parallel to C. If you don't like writing all that out, you could just say something like theorem 3.11, and I'll know what that means and you'll be fine. Okay, so if you don't want to rewrite the theorem, just tell me what theorem you're talking about. Okay? Part B. What do you guys think? So same sort of idea. How do I know that A is parallel to B, though, on this one? So A is parallel to B. Why? Because what type of angles are those? They're congruent, but what type of angles are they? We have a special name, parallel lines, transversal. No. Start with a C.
Corresponding line?
Yes. So A is parallel to B because corresponding angles are congruent. And then it's the same thing. I'm going to write it the other way. Just see theorem 3.11. So once you've established that A and B are parallel, and then B and C are parallel, you can say that A and C are parallel. It's that same theorem. Theorem 3.1, but first you have to show me why A and B are parallel, and they're parallel because of what we learned on Friday, that corresponding angles are congruent, makes the lines parallel. Any questions? Alright, here's the next example. This says find the value of x that makes those two lines, WX and YZ, parallel. So these are same side interior angles. Same side interior angles have to add to what if we want the lines to be parallel? 180. And I know one of them is 90, so I can do 12x minus 6 plus 90 equals 180. I need that to be true in order for these to be parallel. Now, careful here, when you combine like terms, you have to remember that's a negative 6 plus 90.
You gotta go find the value and stuff like that too.
You can just write the equation if you want. Alright, so I need to subtract 84 from both sides. So I have 12x equals, what's that, 96? And then when you divide both sides by 12, you get that x equals 8. So in order for these two lines to be parallel, x would need to be equal to 8. And again, I set this equation up because these are same side interior angles, and same side interior angles add to 180. What are your questions? So part A, we have they're on the same side of the transversal. They're inside the other two lines. Same side interior angles. Now, you have to decide, are same side interior angles congruent or do they add to 180? Same side interiors add to 180. So I need to do 15x plus 90 equals 180. Alright, so I need to subtract 90 from both sides. So I have 15x equals 90. And then divide both sides by 15. So x is going to equal 6. Very good. So you could think of it that way, or you could actually use the fourth theorem that you wrote down today. It says if one line is perpendicular to a line, in order for them to be parallel, they both have to be perpendicular. So you could have just set this equal to 90, or I actually just did it the way we would have done it last week. Either way, you get x equals 6. All right, same thing here. You can use that theorem 3.12. It says that if one is perpendicular, the other must be perpendicular as well. So you could set it to 90 that way. Or these are actually alternate interiors, so they have to be congruent anyway. So either way you think of it, what you need to solve here is 3x plus 15 equals 90. So subtract 15 from both sides. Give us 3x equals 75, and then when you divide both sides by 3, you get that x equals 25. What are your questions? All right, that's actually it for this section. I'll get you guys your homework.